Okay, hopefully the stream is working. Yeah, so I thought I would just continue with the sentiment analysis project that we were working on earlier. I made a few mistakes at the end as I was kind of rushing to head out of the room that I had reserved in the library. But yeah, so we can go ahead and finish up maybe a little bit more of the sentiment analysis project and fix a few mistakes that I made at the end. Also, hopefully the audio will be better in this stream. Yeah, so I think what I'm going to do is, first of all, create a GitHub repo. And what I want to do is pull down a gitignore here. So we'll just basically look at a Python gitignore. And I'm just going to curl this down into a gitignore here, which it should be. Okay, so that looks like it'll work. Oops. We want to curl that down here into a gitignore. What's wrong? Oh, I've already done it. Okay, cool. So we got a gitignore, and I just created a GitHub repo, so we can init here, git remote add origin. And I'll just make this a public repo so that we can continue working on it in the future, and you guys can pull it down if you're interested. So I just made one called Simple Sentiment, and so we'll go ahead and just add that. Probably can gitignore the resources as well, since I'm storing those in an environment variable. So what I'll do is just edit the gitignore to or project resources. You guys can, anyone can pull their own list of stopwords. So that is in a resources directory. And so actually what I'm going to do is just I did not mean to reset all the way back. So we'll curl this down into a gitignore. Gitignore. Probably should have just checked it out, but yeah, we're going to ignore the resources directory. Failed to push, ref does not match any upstream. Okay, my bad. So now this should be a repo, and it's only got a gitignore in it. What is going on? Actually, where are our files? Oh no, did I think I may have deleted some stuff. That sucks. Well, I guess I could quickly rewrite some of the tests and stuff. I have no idea what happened to the files here. Okay, well, we did it once. It shouldn't take too long. So I'm going to go ahead and just quickly rewrite what we had. It should probably only take about 15 minutes or so. So we got this test directory, and what I'm going to do is just go ahead and create test tokenizer. Actually, what I should do is make sure that the env still works, our virtual environment. So source env in activate. And we have PyTest and everything. Man, I can't believe I must have accidentally deleted these files. Anyway, we'll go ahead and make the test tokenizer.py and test sentiment analyzer.py. And then in this directory, we'll go ahead and make the two modules, tokenizers.py and sentimentanalyzer.py as well. Okay. All right, so we don't have any tests. So I'm going to go ahead and write some tests here. So we have this tokenizer. And we'll call this simple tokenizer, and actually in the wrong file. Okay, finally we'll get started. Okay, so I want to test the tokenizer implementation. And this is just going to be a simple test class. And so we had written some tests earlier. But basically the first thing that we want to be able to assert is that our tokenizer can split, or we'll say split string sentence on whitespace. And I'll be right back. Okay, cool. So we want to test that our tokenizer splits string sentence on whitespace. And so given some list, some input sentence of like foobar baz, we can code here using TDD basically by wishful thinking. So like we would like to have some tokenizer, which we'll call simple tokenizer will be the object type. So we want to be able to new up a simple tokenizer and then call tokenize on some input sentence. And from this we'll get a result tokens. And what we should do now is like assert that tokens is equal to some expected value. Or I like to say expected is equal to tokens. Alright, and so what we expect the behavior to be here is given this input sentence, we expect to see foo, bar, and baz. I'm going to try to work through these tests quickly because it was a total accident that I removed those files earlier. So we're going to call this the tokenizer unit tests. So if we run this test, we can see that we need to call self here. Now we'll see simple tokenizer is not defined, so we'll import it. And I called this module tokenizers, so we'll say from tokenizers import simple tokenizer. Oops. Run the test, and we can see that it's not found. So So what I'm going to do is actually should have just edited setup.py, and from setup tools we can import setup and find packages, and we'll call setup if name simple sentiment analyzer. Version is 0.0.1, and packages we just call find packages. Okay, cool. So then we can actually pip install this directory. Okay, and then we can go back into our tests. Run the test. You can see that cannot import name simple tokenizer. So what we want to do is just actually new, and then into tokenizers, we'll go ahead and make that class simple tokenizer. Just an object. Create the initializer, and for now we'll just pass. We know we want this method tokenize, which will take in some sentence. Okay, so now we run the test, and we are going to say, we see that we cannot import simple tokenizer. Did I spell that correctly? Simple tokenizer. Okay, so we run the test, and expected is not defined. It's because I need an equal sign here. Okay, so now we get an assertion error. Foobar baz is not equal to none. That's because our method is currently returning none. So I'm going to follow the standard TDD. Well, I shouldn't say standard, but I'm going to follow a sort of TDD practice here. But I'm going to try and move it along a little bit more quickly since we did this in a previous stream. But given some sentence, the first thing that we can do to do a very simple tokenization is just split and then return. So this is going to split the string on white space. And this should make our test pass, which is good. Then we can assert that it does this case insensitive. So given that some of the letters here will be capital and others won't, we still want to return the same list of tokens here. And that's just to sort of downsample the number of possible tokens that are in like our eventual downstream set of tokens that we're going to do some analysis with. So if we run this as it is now, we'll see that we fail because of the fact that we're not doing anything with the tokens. And so what we can do is call lower here. This should make the test pass, which is good. And the next thing that we did was we want to assert that the tokenizer splits it only works with alphanumeric characters. So we can say that the tokenizer removes non-alphanumerics, cars. And so given that we have like some punctuation in here, we want to go ahead and remove that. Or any special characters. And of course, if we run this test, we'll see that it fails because we're not removing those characters. And so the way we handled that earlier was to import the regex module, and then what we can do here is say like clean sentence is equal to re.sub. We'll write our regular expression here. So we'll say like basically we create a capture group here, and we say like if it's not in A through C 0 through 9, and we actually lower it beforehand. So we'll say like lowered Sent is just sentence.lower. Oops. Okay, lowered sent. Then we're going to return clean sentence. We don't need lower here, and dot split. That should work, so let's go ahead and run our test. So we get an assertion error here because the regular expression, we need to make sure that we don't remove spaces. We're going to split on those here. So the regular expression should not split on spaces. Still get an assertion error here. It's because I didn't save. So don't split on alphanumeric, lowercase. Yeah, I think I just didn't save. No. Foobar baz is not equal to this. So we still have some white space to split on here. Tokenizer, we tokenize the input sentence. Take the lowered sentence and we lower the input sentence, and then we sub non-alphanumeric characters with empty string. Oh, made stupid mistake there. Okay. Okay, cool. So now all of our tests should be passing. And then the next thing that we did with our tokenizer was we removed stopwords, so we can test that the tokenizer removes stopwords. So given that we have some sentence here that says like a foo is the r baz, we still want foobar baz because our stopword removal will remove like the articles and the auxiliary verbs and that sort of thing. So we'll watch the test fail because we have these extra words in here, and so now what we need to do is go ahead and bring in some stopwords. So what I'm going to do is create a class adder here called stopwords, and we're just going to call self.get stops. Hey Ubaid, where are you actually working on, or what am I actually working on? So I'm working on a simple sentiment analyzer to do some basic English natural language processing. And so we're just building some NLP tools from scratch here to work on that we can use with projects later on. Good question. So cool. All right, so we're going to create this class attribute stopwords, and we're going to get that using a function that we'll write here called get stopwords. So I'm going to take a slight detour from TDD here for a second. Kent Beck would be very disappointed in me. Actually, he probably wouldn't care about me too much. All right, so we're going to get stopwords here, and what I'm going to do is pass for right now. And what we did earlier was get a list of stopwords from GitHub. So I'm going to try to pull those down again. Looks like it was these. So we have an English stopwords collection, which has a bunch of words in it that are considered to have like low semantic value. All right, cool. So what I'm going to do is basically just curl this down. Yeah. All right. So cd into projects. We're going to go ahead and make a resources directory. Cd into resources. And then we're just going to curl this into a file called stopwords. And then we can just make sure that it looks good. It looks good. Actually, let's make sure that the end of the file looks good as well. Yeah, so we've got this little percent sign, so I'm just going to clean this up a little bit. Actually, we could have tailed that. All right, cool. So that looks good. And then what I'm going to do is actually in a new pane here, I'm going to go ahead and create an environment variable. Ubaid, it is not too advanced, I don't think. Yeah, it's just going to be some basic Python, and you know, we're going to write like a really simple version of a tokenizer and a really simple sentiment analyzer. So yeah, hopefully it shouldn't be too hard to follow along, but I'm going to go ahead and push all this code up to GitHub as well, which reminds me I should commit here pretty soon. But first, what I'm going to do here is actually just edit my virtual env bin the activate script, where we can set we're going to go ahead and set some environment variables here, so you can see like actually this was part of my virtual env, or this was part of the repo which I didn't accidentally delete. So I've got this stopwords list here, and I think we just called it stopwords. And I'm exporting positive word list and negative word list for when we do sentiment analysis as well. So we've got this stopwords list path. Each of these are actually paths to some to text files that have words on different lines. Hey Ronnie, yeah, I accidentally like deleted everything in the first directory, so I'm just trying to rush through and kind of redo what I did in the first one. So sorry for the sort of repeat material. It was pretty frustrating that I kind of hastily deleted everything. So I'm just kind of recreating it from scratch, but hopefully it only takes about 10 minutes from here. Yeah, I know, it was a total bummer. Okay, so we're going to go ahead and source env activate again. I did create a GitHub repo this time, and so yeah, I'll push it up to GitHub. So we'll go ahead and git add, and we'll get commit, initial commit, and we'll go ahead and git push. And the GitHub repo is here, so you guys can find it there if you're interested in following along. Alright, cool. So what do we have now? What's going on? We need to go back into our tests. Test tokenizer. So we rewrote these tests. We're now just failing on stopwords, so we can go ahead and head back into our tokenizer where we're getting stopwords, and what we can do here is basically try to open up that that text file that we have now with stopwords in it, and so we can see that in resources stopwords. So our stopwords path we've saved out to an environment variable. And I just called it, I think we just called it stopwords path, if I'm not mistaken. Dang. What did I call this? Activate, and then we'll go ahead and echo stopwords list. I thought I called it path. Yeah, stopwords list. And then with this path open, so with open stopwords path, as f, we're going to have this list of stopwords that we just append. So for line and f, we'll go ahead and stopwords dot append. Stopwords that append line dot strip. That's going to take out the new lines from each line in that file, and then we'll make sure that we return stopwords when we're done looping through the file. And so then when we tokenize, rather than just returning that list of tokens that we created with the regular expression and splitting on white space here, what we can do is we'll return word for word in that if word not in self.stopwords. Okay, hopefully the logic is correct there and our test should pass. OS is not defined, so we need to make sure we import that. Now we run our tests. Expected string bytes, not none. So stopwords path there is not loading. So I think I need to activate and then make sure that stopwords list exists, and it does. And in fact, if we check that out, it does have our stopwords in it. So we'll head back here, and still getting none type here on with open stopwords path is equal to, is that right? os.environment.get stopwords list. So what if I maybe missing something here? I'm going to check out the chat as well. Okay, cool. Let's, so we're basically getting none here for stopwords path. Get stopwords list. So source bin activate. We'll come into Python here and we'll import OS, and x is equal to os.environ.get stopwords list. Okay, that's nothing. So what did I call that environment variable? Go env bin activate, and we'll look at the script again. Stopwords list is what I unset here. Stopwords list. Oh, I'm exporting nothing again. So I don't know why I changed this earlier. So I set it as something and then I exported it as something else. So hopefully this will work now. So we'll go ahead and source it again. Actually, I need to source it here. And now we can actually vim our tests. And so we have 4 passing tests, so that's cool. So that is about all we did with the tokenizer earlier. So that's good. And now what we're going to do is write our simple sentiment analyzer. And so hopefully we can sort of do this from scratch again really quickly. We'll do it TDD as well, so we won't start with the code, we'll start with the tests. So we'll test our sentiment analyzer. If I can spell correctly. And then so our first test was to test sentiment analyzer should return positive score for all positive words. And by all here, I guess I mean like if all of the words in a string are denoted as positive, then our score should be positive. So given that we have some list of tokens, so like if our tokens are like all good words, like good, happy, wonderful, and we have some sentiment analyzer object, which we'll call simple sentiment analyzer. And that object has like a score method on it that we pass these tokens. Then we just basically want to say, like, given this score, we want to assert that the score is greater than 0. So again, it's going to be a really naive sort of rules-based sentiment analyzer, but it'll be enough for a simple project. I did not mean to close that. Okay, cool. So obviously if we run this test, it's going to fail, saying simple sentiment analyzer is not defined. And so what we can do is go ahead and create it. So go ahead and import it from sentiment analyzer, import simple sentiment analyzer. And it's kind of a bummer that I have to do this from scratch again, but it's really not too much code, so no big deal. I call this simple sentiment analyzer. This will be an object. So we'll create an initializer, and we'll pass, and then we're going to have some method score here, which will pass, but this is going to be responsible for returns a score returns a sentiment score for a provided list of tokens, like string tokens, we should say. Okay, cool, and yeah, we'll pass, and this class for a docstring we can say is just like responsible for scoring a list of tokens on sort of like a not binary, but like on a single dimension. So like basically the polarity, like for scoring the polarity, like the sentiment polarity, or something. We can reword that later. So that's all looking good. I'm going to write this test, and then we'll go ahead and make another commit here. So blah blah blah. So we test. Now we get a different failure. Score takes one positional argument, but two are given. So we'll go here, and so it's going to take some sentence, and okay, I could just test again, and then we'll see the assertion error. Well, actually, we see a type error because greater than is not supported between none type and int, because we're returning none here. So the simplest thing we could do is to return 0 to get it to pass. If we were doing like hardcore TDD. But yeah, we wrote this once before, so kind of know what we need to do here. And so the simplest implementation that we sort of came up with earlier was in the initializer, we're going to get a list of positive words as a class adder here. So we can say like self.get words for the environment variable to the path, like positive words list. And then for negative words, we'll get words for negative words lists. So we'll go ahead and create that, get words self, and it takes some path. And then sort of just like in the tokenizer, when we're gathering stopwords, we're going to do something very similar here to grab the positive and negative list of words. So like words is going to be an empty list, and the path is going to be well, we need to, the path is stored as an environment variable, so we'll just say like with open os.environ.get path as f. We can go ahead and actually for line in f, words that append line.strip. Okay, cool, and then we need to go ahead and make sure that we return words. And the other thing that I want to do here is make sure that the environment variable matches what I expect here. So source, and then we're going to go ahead and echo out positive word list. Okay, it's word list Okay, cool. Now we need to go ahead and curl those positive words back down, which again we did earlier. We'll just go to GitHub and look for some positive words. And there were a couple gists that had like one with positive words and one with negative words. So we'll go ahead and open this guy up, raw, and then we'll do the same with negative words. Okay, cool. So open this guy up, and then in resources, we got this. So I'm just going to go ahead and curl this down into one called positive words, and we'll curl the other one down into a file called negative words. Hey Lover PHP, this is we'll be working with Python for this project. Maybe we'll do some Node in another live stream. That would be kind of fun as well. So yeah, all right. So now I've got these two files, and I just want to clean them up really quickly. So I'm going to pop this out, and then we will go ahead and clean up these two files. All right, so it looks pretty good. So they both had some headers on them. And so now we've got our positive and negative word lists. And I want to make sure that I exported the right path. Yeah, I think I did underscores here. Okay, cool. So I'm actually just going to save this. Oh man, what did I do here? This file's been changed since reading it. Oh wow, that's an old one. Yeah, I should not have kept this buffer open. Alright, so we'll source this pane we can close, this pane we can close, and then I don't want to commit with a failing test right now, so we'll head back into our tests and make sure that well, the tokenizer test should pass. Actually, the sentiment analyzer tests we need to get working. So here, so we'll run this test. Actually, we need to make sure we run this test. Okay, cool. So name OS is not defined. So let's see if we can create a new buffer, and we'll edit our sentiment analyzer class to import OS, which we're using here to get the environment variable to both of these paths. Okay, cool. So we can run this test. Type error greater than is not supported between instances of none type and int. So score is still none here. So let's go take a look at our function. And that's because we're not doing anything in our function here. So now that we have our list of stop words, what we're going to do to get some like the most bare bones type of sentiment is to like create some score, and we'll start it out as 0 and we know we want to eventually return it. Okay, cool. And so like then what we want to do is like look at each token in our sentence, and so this shouldn't really be sentence here or send. We should call this tokens. And what we can say just very crudely is for token in tokens, we can say if token in self.positivewords score plus equals 1. elif token in self.negative words, score minus equals 1. So yeah, this is pretty crude. This is going to miss out on lots of things. For one thing, it's going to miss out on like negative prefixes, if you will, or words that like come before the positive or negative word. So like if I said like the food was not good, this particular implementation is still going to think that that's a good or a positively scored sentence because of the fact that it sees the word good and we're not handling we're not handling the negation. So that'll be something we have to do in the future. And then we have this elif here. So it may be the case that there are words which are in both positive and negative word list, in which case this if elif will actually cause the score to be positive. If they were both ifs, then it would negate. Like if for some reason these two word lists were not mutually exclusive, like they weren't sets, then basically we would see the sentiment like negate itself in that case, and we'd end up with 0. Okay, cool. So keep mashing the keys and recording macros. All right, so we're going to return the score here. Let's see if the logic is correct. So it's good, so our test passes. Likewise, if we say like test should return negative, score for the case where we have all negative words. So like bad, unfortunate, horrible. Then we want to assert like that this score is less than 0. So we can run that test and we can see that that one passed as well. Likewise, if we have all neutral words, and this was a mistake in the last live stream, I think when I was in a rush, I said should be negative, should obviously be neutral. So like it should return 0 score for all neutral words, like for the case in which it's all neutral words. So like house, table, chair, cat. We should see that the score should be 0. Okay, cool. So if we run all these tests, so we've got 7 passing tests. I am going to do one thing here. Actually, first we can go ahead and commit simple sentiment analyzer. Push that up. Okay, cool. If you guys want to check out the GitHub repo, it is there. Okay, cool. So now we're basically back to where we were at the end of the first live stream before I accidentally wiped everything. Although I didn't parameterize tests, and just to get like 1 or 2 of those in there, I'll go ahead and just parameterize one of the tokenizer tests. To do that, we need to import PyTest. And then here what we can do is just decorate a test method here with pytest.mark.parameterize. Some input value and then some expected value, and then a list of tuples here. And we'll say like if we're given foo bar baz, we expect to see a list foo bar baz, and then we have our input and our expected. What did I mess up here? Invalid syntax. Def test tokenizer. Oh, we need to close this. Okay, cool. So now we can actually test our edge cases without writing a whole bunch of extra tests here. So, for instance, move this here. And like the case where we have nothing, then we should get empty list. Case where we have like one long word, we should just get one word. That looks good. And then likewise, if we have like just a space or something, what should happen here? We should get an empty list. Okay, cool. We could parameterize a bunch of these others to check out edge cases. I'm not going to worry about that too much right now. Maybe like, yeah, well, we can do that later. We did this earlier, so say parameterize test. All right, cool. Okay, so what do we want to do now? Basically, we've got like a simple sentiment analyzer, and we can even see that like if we have some sentence here, like sentence is, I had a fantastic day, and then we import whatever our module is called, I think. Like from tokenizers, import simple tokenizer. Oops, sorry. Yeah, from tokenizers, import simple tokenizer. And we tokenize our sentence. So you can see that the only words left were fantastic and day. So if we set that to a list like of our tokens here, oops, tokenize, and then actually we should also import our, what do we call that module, from sentiment analyzer, import, what do we call this one? Simple sentiment analyzer. I did it again. And then so we called that essay, and I'll just go ahead and remove that pane. So essay is equal to a new simple sentiment analyzer, which takes no construction arguments, and then we can just say essay.score our tokens, which I think I set to tokens. We can see that it gets a score of 1 because tokens has like one positive word in it. So likewise, if I had another sentence that was like good, fantastic, excellent, oops, and we wanted to tokenize that, we can just say s.tokenize a. So we've got a new list of tokens here. And yeah, so now we've got two words here, fantastic, excellent. Interesting that good didn't come out. So do we have a subtle bug here? What did I do here? Let's go back into the tests actually. And we'll go back into the sentiment analyzer test specifically. For token in tokens, if token in self.positive words is good, Alright, so let's actually cat out resources stopwords and we'll grep for good. So yeah, good is actually a stop word, which is interesting to know. So in fact, if we want to we just want to make sure here that everything is working as we would expect. So like if the token is in positive words, then we score plus equals 1 or else minus equals 1. Oh yeah, this is good, but in our tests, we want to be explicit about the score actually. So like not that it's greater than 0, but in this case it's 2 because we know good is in a list of stop words. Oh, and actually, in this case, well, this is testing explicitly whether or not this word is in the list of positive words. This is kind of interesting. So it is going to be 3. We're not actually doing a sort of integration type test where we're testing both the tokenizer and the sentiment analyzer together, in which case the score would be 2, because the tokenizer would remove good because it's a stop word. But were it to be in the list, the sentiment analyzer would give it a score of 1. So likewise here, the score should be -3. And so now it's looking good. Okay, so let's do something with this sentiment analyzer. Like, what if we wanted to get the score, the sentiment score of like an entire book or something, or we could do a bunch of tweets. I think we'll start with Gutenberg, where we can pull down some texts that are in the public domain. So if we go to top 100 list of this, let's compare Christmas Carol to like Heart of Darkness by Joseph Conrad, and I wonder if Old Man and the Sea is in here. I don't know if that book's in the public domain. Hey David. So yeah, like I don't think Hemingway is old enough to be in the public domain, but certainly Christmas Carol and Heart of Darkness are. So what we can do is actually we'll curl this stuff down, and I'm not going to worry about doing any kind of like too much pre-processing. We're just going to pull down the raw text, and so go ahead and quit this, and maybe in resources. Maybe we'll have a folder in here for resources for like, make a directory called sample data or something. And then I'm just going to curl this down into, which one was this? This was a Christmas Carol, I think. Yeah. So we'll curl this one down into Christmas. And then another one here we'll pull down into Heart of Darkness. Alright, cool. So let's take a look at these. I'm going to do some like super rough cleanup here. So we'll just go ahead and clean some of the language up here a little bit. So we've got this, it's got a preface, then we're going to remove a bunch of the stuff about Gutenberg from the bottom. I'm pretty sure there are tools to do this in Python that people have written that try to do a lot better job like cleaning out the license and a bunch of the sort of cruft here. All right, and so as Tiny Tim observed, God bless us everyone. All right, that's great. So that one's good, and then we're going to clean up Heart of Darkness very quickly as well. Again, just kind of like roughly cleaning up what we're seeing in here. So we'll come to the end now, and we'll take out a bunch of this cruft. End of the book, end of the book. It would have been too dark altogether. ... All right, cool. So we cleaned up a couple of sample texts. Now, one thing about like these texts is that head heart. Well, maybe let's like head heart like 40, yeah, 30, whatever. What's the arg there? Tag 30. Oh, it's probably head dash 30. So we've got sentences now. So we've got more than just like this. We don't want to take this in as like one giant string, although that's kind of interesting. We could take in each text as one giant string with our tokenizer and then see what its overall score is with the sentiment analyzer. Actually, that's kind of funny. We could take a look at that first, but really what we want to do is split on sentences next. So we want to look for characters or patterns that basically serve as delimiters for sentences, and then we can split entire books up into lists of sentences, feed those through our simple sentiment analyzer, and then maybe we can look at like how the sentiment of a text changes over time. We can get a kind of like polarity score for the sentiment of a book in the time dimension, which is kind of interesting. But first, yeah, if we want to do something really simple, what we can do is just write a script for it. So we'll head back into our tests. And we need to get up into our tests. And so the way that our tokenizer works is we just like new up a class here. And we new up a class and we have a single method on it. So like tokenizer just tokenizes. The other method's sort of a private method just to get stopwords from an environment variable. And so this is going to take an entire string. So if we can read a file like from disk into a single string, then we can tokenize it all, and then we can sort of pipe that, if you will, into our sentiment analyzer, which just has a single public method, if you will, score. And we can see how that works. So I'm going to create like a run script, I guess. And actually, I'll just do that here. We're going to go ahead and dash run. And we don't even need to make a class. We're just going to run a script. So what we'll do is we'll say we'll have a tokenizer, which is a new simple tokenizer. Is that the name of the object? Yeah, simple tokenizer. And we'll tokenize some sentence. And we'll basically just open it from disk. So like with open, and then like the relative path from this script would be resources / could make this an environment variable too, but just to test out a simple script here, we have like sample data. Let's do Christmas Carol first. As F. We're just going to stream that whole thing as a string into our tokenizer, and we're going to tokenize it. So we're going to get a huge list of tokens out. And what we'll do is have a sentiment analyzer. To basically score those tokens. So we'll need to say from tokenizers, import simple tokenizer that we wrote. And we wrote a simple sentiment analyzer in this module. From sentiment analyzer, import simple sentiment analyzer. So then we knew an instance of each of those objects up, and we used them to do a tokenization and simple scoring. And then maybe for the case of this script, we're just like print out the score. Score for was this. Should just say like path or whatever. All right, so here, simplify things and make sure it's working first. Score. Okay, so that should be good. And the context manager will make sure that the file gets closed. All right, so next, what we can do here is we should just be able to run this. And so I'll do it in the same window in a different pane here. So yeah, we can actually just python run.py. So I have a typo. We could have TDD'd this script as well. Okay, invalid syntax on line 11. Missing a parens. Okay, coercion Unicode needs string or buffer none type found. So is this in the right place? Do I need to do something like this? So it's saying none in terms of stopwords path. Oh, because I'm not in my virtual environment here. So our stopwords was in stored in an environment variable. And we set that in our virtual environment. So env bin activate script is where we can export those. So we have this stopwords list, which when we're running the script, we need to make sure we're in our virtual environment. Okay, so text.io wrapper object has no attribute lower. Oh, so we've got like a text stream coming in here. Do I need to do something like RB, like buffered reader? Text.io wrapper. So I think I'm not opening this up into a string correctly. So let's actually, if we open up dash and get a refresher on here, or we could just hit up Stack Overflow as well. Python read file in the string. With open text read is my file. myfile.read. Okay, so we need to actually call .read, and yeah, in this context manager here, we could specify explicitly that we want to read the file, and the entire text is f.read, and then we're going to tokenize text. Alright, cool. So now we'll run, and we get a score of -237 for what? For a Christmas Carol. So that's interesting. Again, this is like probably pretty incorrect because of the fact that it's not counting like cases where a positive word is preceded by a negative signal, like not or never, that sort of thing. But nonetheless interesting, we do get a score out, and for all intents and purposes of this naive sentiment analyzer, it's negative. So let's see if we were to pull in Heart of Darkness. I've actually not read Heart of Darkness. or any Joseph Conrad, but it's supposed to be pretty good. Sounds like it may be negative. I think it's about the Congo. So yeah, we get minus 687 sentiment score if we read all of Heart of Darkness into our sentiment analyzer. So that's pretty interesting. Maybe we'll do one more quick thing, which would be like if we check out Kaggle and we pull down some tweets or something, or we pull out some other text data. I'd be interested to see. Feel free to type in the chat if you have ideas about stuff we'd like to test against our sentiment analyzer, and then we can see how it changes over time also as we improve its functionality. Alright, so let's look for like some comments. Reddit comments. Positive or negative sentiment, what do you think? 8 gigs of comments. Let's see if we have anything that's slightly smaller size, perhaps. YouTube. Sarcasm. It would be interesting to see if we could build a sarcasm detector somehow. New York Times comments. Eurovision. Video game comments from Metacritic. Alright, here's some comments from Reddit. And it's a pretty small, actually super small data set, so we're just going to go ahead and download this one. And I'm going to go ahead and open it up here. And so this is a CSV. We should use like pandas and build some proper pipelines here for like if we're going to build out a sort of more robust platform. But since we're just building like a component of it, which is to do basic sentiment analysis, then maybe I'll just read like, what we can do is like we can read every line in a CSV and we'll just stringify like, oh, I don't know, let's take a look at the CSV and see what it looks like, and then we can decide what to do with it. So it's kind of fun playing with the with a couple of texts from Gutenberg. And let's move the CSV here into our resources. Oh, we're already in sample data, so we'll just move it here. And I'll go back into our root directory and we'll go ahead and make another commit. So like, what did we do? We added a simple run script. Okay, cool. Let's just do another script here. We could do this TDD as well if we want. Like, what if we build a simple CSV reader? So yeah, we can do that. We can go into tests and tests CSV sentiment analyzer. No idea why we would build one of these, but it might be pretty interesting. So did I create that in the incorrect directory? Oh no, I just didn't create it. So yeah, I'm going to touch that, and then we'll also touch the file that we'll use to write code for that as well. CSV sentiment analyzer.py. So let's head into our tests. So our CSV sentiment analyzer, and what we could probably do here is like, I wonder if we should just subclass our sentiment, our original simple sentiment analyzer. But yeah, I mean, I don't know, I'm just trying to kind of think about it. Let's worry about abstraction later. And for now, we will just reuse, we'll sort of do a more like composition rather than inheritance, and we're going to just have our CSV sentiment analyzer have a test or have a simple sentiment analyzer, if that makes sense. So class test CSV sentiment analyzer. And let's test that our CSV sentiment analyzer can read CSV. How are we going to do this? Maybe we'll try to score each line, score each line of a CSV, assuming that our comments are going to be just one record per comment, and then we'll have some feature columns, probably with username and the comment and probably the date or something. We should explore that data. But in any case, what we want to be able to do is we want to test that our CSV sentiment analyzer can score all, score maybe individual rows of CSV. And so given that we have some CSV sentiment analyzer, and let's say in this case that when we new up a CSV sentiment analyzer, we do pass it some file path. So if we were going to do that, we could mock something out here. I don't have too much time left, so maybe we'll save this for a little bit later. But in the meantime, maybe what we could do is we could just play with pandas and do this inside of a notebook to start. But in any case, we'll do that in a second. So what we want to do is say that we want to score this CSV, and we pass this some file path, and maybe we have some fixture files here. We would create some score, and our test CSV maybe will be we'll have a positive test, and we want to assert that the score for the whole CSV is greater than 0. Test, and this test would actually not be bad. That would be, we would test that the CSV sentiment analyzer scores a net positive CSV as positive. And then we would do the same like we did for the regular sentiment analyzer if we had a negative list of comments or that were net negative. Just do a quick docstring here. Okay, cool. We can watch this one fail, and we'll write our CSV sentiment analyzer in the next stream. So let's play around just for a few minutes with Jupyter, and we can check out how we might. Shouldn't commit a failing test, but we'll test. Just call it start CSV sentiment analyzer. Alright, so that's cool. We'll pip install Jupyter in our virtual env. And I should have installed pandas as well. Pandas, NumPy, and maybe later we'll take a look at things like GenSim for some topic modeling. We could use scikit-learn and TensorFlow and Keras to do some machine learning. And Spacey is another good one. So I'm just going to go ahead and install these in the virtual env, so there'll be things that we can look at in a future live stream. So pandas, if anyone is new to the sort of Python data science ecosystem, so pandas is a library that helps us create and manage data in tabular format using data frames. So it's similar to like R data frames, basically creating tables of data or rectangular structures for working with data. Not sure where my pip install was here. Oh yeah, sorry. It's gonna be down here. NumPy is a ubiquitously used library for linear algebra in Python. So working with like data in NumPy arrays. GenSim is used for doing topic modeling. It's a really interesting library, and it's another NLP library that we could get into. sklearn has things that help us do some basic machine learning and sort of data prep, so we can transform and do estimation on data. TensorFlow is obviously Google's sort of, what you call it, like graph calculator. I don't know, but basically used for doing creating neural networks and doing any type of sort of lazily evaluated computation. Keras is now actually built into TensorFlow, I believe, but sort of provides you with a higher level API for building neural networks and doing deep learning. And Spacey is just a really fantastic sort of heavyweight NLP library that does all sorts of things, like has very robust tokenizer, much better than the simple one we started building, and does like dependency tree parsing, and can help us create word vectors and do all sorts of really fun things. All right, should be finishing up here shortly. It's interesting, you see like Boto 3, Boto Core. So Boto is like a library that's used to interact with AWS or Amazon Web Services. So I wonder what library uses that. That's interesting. URL Labs, Side Tools. I think URL Labs is built-in. And it looks like it's got to reinstall some version of setup tools that's compatible with this stuff, but it's installing NumPy, Pandas, SciPy, Boto, URLlib. Probably didn't need to install all of this in one go, but it'll be here for future streams. Maybe in the meantime, I wonder if, while that's installing, if we pip freeze and see just if Jupyter is available. No, okay, should be now though. Actually, not before we source spin activate, which doesn't matter because it looks like it finished. So now we've got a bunch of packages available, and we should just be able to run Jupyter Notebook here. And we'll go ahead and create a new file using Python 3. And now we should be able to import pandas. And cool, so what we can do now is we're going to create a data frame and basically read that CSV that we downloaded with those reviews into it. So we can just use pandas, so we'll import pandas as PD, and the data frame here will say pd.read CSV, and then we just provide it with the path. So we had this resources, test data or sample data, Reddit comments.csv. And if this was like a huge file, we could even stream it. So we could set like a chunk size, and then make some reasonable chunk size to read this in, and then it gives us an iterator that we can sort of stream over. But for now, we'll just read in. And so if we check out the file, it's actually really clean. It looks like we've just got a single column called body. Nice. So like, we could even just write a function that like applies our tokenizer to this body column and creates a new column. So I don't know if I remember how to do this from scratch, but like if we wanted to create a new column called tokens, I think what we can do is df body dot apply this function tokenize. And if we come up here and say from tokenizers import simple tokenizer. Okay, so that works. And we should also from sentiment analyzers import simple sentiment analyzer. No module name that. Okay, so from sentiment analyzer import simple sentiment analyzer. Let's try to see how we can tokenize this column of string sentences. I'm pretty sure we could do this. Well, I know that we could do this in a couple of different ways. Let's look up. Actually, we could use dash. And then here with pandas, we can search for the apply method. And actually we want to do like apply to a series. Basically apply a function along an axis of the data frame. Do we want to broadcast? So like we want to apply something to each row. So this isn't like a static function. I wonder if we could still can we import like simple tokenizer.tokenize? Yeah, so we can't really do that, but we have this simple tokenizer object, and I wonder if we can just apply simple tokenizer dot tokenize axis 1. Tokenize got unexpected keyword argument axis. What if we say function is equal to this? Required one positional argument sentence. Yeah, so I need to figure out how to do that. So let's go ahead and apply a function to column and pandas. So yeah, if we wanted to use a lambda, we could. Check out Jonathan Soma's blog. So in this case, he does take an input here, and he returns. He just calls it directly on a column. Right, but this is just a function. This isn't like a method. Maybe I could just, well, I could declare the method. I could make it a function, or we could maybe make it a static method. How does the lambda work? I wonder if we did something where we created a lambda and called our function using an object that we created. So like, if we said tokenize was lambda x, and then we had our tokenizer, we called tokenize on x. And here our tokenizer was an instance of a simple tokenizer. And then we just called apply tokenize. Yeah, I think that this is what we want to do. It's taking some time. Should have actually called like .info or something on the data frame and got a look at how many rows it was, or .describe, I think. All right, cool. So we've got our tokenized list here, and yeah, if we do like df.describe, this is going to give us some information about, in this case, just like how many rows are. That's interesting. Unhashable type list. If I do info, which I did not mean to pass an empty tuple, but it's only 15,000 rows. So like length of data frame dot index. Is this how we call it? Yeah, 15,000 rows. So it's not too bad. Cool, but now let's take the sentiment of each one of these. So what we could do is say like df sentiment sum, or sentiment score, is equal to df tokens dot apply centralize sentiment. What's the verb to score the sentiment? So we'll just say score sentiment here. So we need a function to do that actually. So we can say score sentiment is a lambda x. Should just make these like actual functions instead of lambdas. But that's okay. Sentiment analyzer dot score x, and we need to new up one of those. So SA is a simple sentiment analyzer. Tokens. So df.tokens.apply this. Maybe do we need to specify the access in this case? I feel like we do, although it's trying to pass that as args into the lambda. Score is missing one positional argument, tokens, which I thought were passing in here. I could do something that you're not really supposed to do. I could do like for row in df tokens.iterRows. Actually, this may not work. Yeah, series has no, so we can do iterRows on the data frame though. And what I can do is say SA.score SA.score row of the tokens. Indices must be integers or slices, not strings. So actually, what does this give us back? It should give us back, yeah, each of the rows, and they come back as tuples. So like if we print row 1, this is probably the tokens. I'm gonna go ahead and restart or stop the kernel here and restart it, because I did not want to run that against all of the rows. It's gonna take a little while to run the score again. What if we wanted to do pandas apply with args? We could use functools partial. You can actually pass args here. Okay, so there's a keyword argument args, which is a tuple. So if we wanted to do percent score, it should be df.apply score sentiment with args equal to, like here we just want it to be the value at the index that's currently happening. So I'm wondering how we actually apply this. This is something else. Yeah, we just need to specify the axis, I thought. But it seems to think that score is missing one positional argument tokens. Oh, we need to call it, yeah, right now we're calling it on the entire data frame. So I wonder if there's a way to pandas apply to series. Yeah, we should be able to, no? So df at tokens. Lambda got an unexpected keyword argument axis. Well, maybe we just do this now. Missing one positional argument tokens. Dot apply lambda x. Oh, yeah. Score sentiment. That's exactly what we're doing here with the score sentiment function. Score missing one positional argument tokens. And I thought that would be the value here. Series that apply args 5. If we did something like this, what if we said lambda x sa.score x If I were to do something simple like sa.score df of tokens, the first index, yeah, this is interesting. Score is missing one positional argument, tokens. Self. Oh, I'm an idiot. I was referencing the class and not an instance of the class. I'm such an idiot. Okay, in any case, now we're creating this new column called sentiment score. We'll insert a cell below, and this will be interesting. Now we'll get like some crude estimation of the sentiment for every comment in this data set. So yeah, that previous bug was because I was referencing the class simple sentiment analyzer and not an instance of the class with these two parens. Alright, cool. So now we should actually be able to see, like if we df.head, we can see the various sentiment scores for each, so that's pretty cool. Looks like we have a pretty negative heavy, probably set of negative words in our list, because I see, like for instance, both the novels that we tried to analyze. If we head back to wherever those were, like when we did this, oops, actually we need to source activate. When we looked at Heart of Darkness, for instance, we saw this negative score of negative 687. And oops, I did not mean to do that. And when we did the other data set here, which was Christmas, we also got a negative value. So my gut tells me that probably like our list of negative words either contains like many more English words or words that just occur more commonly versus our list of positive words. And again, this is really crude. It's just like a rules-based sentiment analyzer, but actually an interesting thought would be to know like the general polarity of a language, like not the polarity of a language, but try to quantify how many words in general have a negative or positive connotation if we're just talking about polarity, and to see whether or not like there are more words to describe things which are considered negative, or are there more words to describe the opposite, which would be interesting to think about. And that would tell us that there's some inherent bias in our score just due to the number of words in this particular type of algorithm. Words that would occur with more or less frequency. Alright, cool. So like if we wanted to get some idea of like the sentiment of the entire data set, we could probably just df sentscore.sum. And yeah, we get this incredibly negative score, summing everything, which is pretty interesting. We could look at like the average score, which is it's almost neutral, which is interesting. Which means there must be some outliers, right? Like if the sum of the entire set is like incredibly negative, and the average is very close to neutral. I wonder what that kind of means. Like if we were to take the median, for instance, interestingly the median is exactly neutral. So what if we were to plot this somehow, like create a histogram? I think we can do that. NP histogram from pandas column. used to do this more often. pd.cut some value into some number of buckets, sort index. Let's just work with this. So we got our data frame and we want to do cent score sort on the index. Cool. Now let's go ahead and create a histogram for that, which would just be, I think that's built into pandas, right? So we just call hist on a series. Okay, so let's say we do this. Is this a series? Yeah, so we should be able to do like s.hist maybe. No module named matplotlib, so let's go ahead and install that in our virtual env. And then we can head back. There's a couple libraries that make these histograms look nicer, make matplotlib. Don't we have to do like plot.show or something? Hist. Matplotlib show histogram. Figure plot.subplots, etc. I'm not very well versed at all in matplotlib. Create some histogram. There is like a dot show method. So let's go ahead and import matplotlib.pyplot. There we go. That looks horrible. So something is clearly not correct about something here. So if I'm reading this correctly, it looks like that there are 26 comments in our set which have some positive score between the values of 9.7 and 17. And we should see some type of really tail-heavy distribution here where like the majority of the comments are between -5 essentially and 2.4. I'm wondering what I'm seeing here does not look at all correct. So let's look back at the histogram, like how this should work. X, Y, looks like they're doing some random numbers to show a normal distribution. Hist. So what if we set our number of bins to something here and do this a little bit differently? Actually, I wonder if we just call .hist on the tokens series directly from the data frame, like df, or not the tokens, if we df.describe again, or df.head, we can see on the sentiment score here, so if we did cent score.hist. Okay, that's better. Although, it is a pretty interesting distribution. Doesn't look entirely appropriate, but let's see. Wonder if there's a way we could get more bins here. So number of bins is set how hist bins is equal to number of bins. So I think if we specify bins here, and let's go up to like 30. Okay, we start to see a little bit more of an interesting distribution. It's not tail heavy, actually, it's the opposite because I don't know what you would call this, like nose heavy. basically it's heavier towards the front here, which in this display here is negative. So this means that there are lots of outliers here where we've got like some comments in here which just must be extraordinarily negative, which is kind of funny. But most of them you can see are really between -10 and 10, with really close to being distributed evenly around neutral. So that's interesting. So I wonder if I get a sample of some comments whose sentiment polarity is like below 30. If we look up DF sentiment score, I think that the syntax is like this. Oh, sorry, yeah, be less than -30. Let's do less than -40, and then we'll go ahead and just grab the body. Yeah, so now we get some super negative comments, which is really interesting. Very interesting. Let's pull like one of these out just to kind of see what it looks like. How would we do that? We've got body. Can we do like this for row in this? Print row. Yeah, so now we can see some super negative comments. Oh, this is interesting as well. Something I didn't really think about is the fact that some of these comments are really long, first of all. And so this is actually really interesting, and it shows like a strong limitation of our implementation, which is that if we look back at how we've constructed our tokenizer, our sentiment analyzer, I should say, we're just on a per token basis. We're doing +=1 if that particular token is positive, or -=1 if that particular token is negative, which means that for a longer set of tokens, we essentially are able to scale that score, without a bound, without an upper or lower bound. So if I have like a comment which is something like this movie was totally excellent, that's a very positive comment. But if I do, if I expand on my ideas in the comment and I have other words sort of adding to or decrementing the sentiment score on a per token basis, then it's not really in a sense measuring